applications are very different from how we used to architect our applications. So it is now data first instead of coding first. So for the last 20 or 30 years since software engineering was born, software engineering has been built on a code first foundation. So meaning like in traditional software, the code was the ultimate truth. We call this deterministic. So what does deterministic means is that it means that if the input is A, right, the code will always give me B. So this is deterministic. The output will always be the same. So it's like a function. The function, the output will always be the same, right? So it follows a strict rule. The logic never changes until we change the code. So what happens if the application broke? If the application broke, we knew exactly what to do. You went to the code, you debug, you found the bug, and then you fix that line of the code. And now that the problem was solved, we trust the process because it's basically just a function, right? But today, we are building AI agents. We are using large language model, LLM. So the world is totally different. So it's not deterministic, it's probabilistic. It's the nature of LLM. It's all about probability. So the model makes a guess based on probability. In this world, the code is rarely the problem. The engine is usually fine. So if an agent fails, if your AI agent fails, if it gives a wrong answer or it hallucinates, give like something that's nonsense, you usually don't rewrite your Python script. You don't rewrite your workflows. So what you look at, instead the problem lies in the data and what the model settings. So did the AI get the correct context? Did I choose the right model for the job? What was the prompt that I give the AI clear? Or is the knowledge base accurate? So it's doing RAG, is it RAGing the correct documents? So we must shift our mindset a bit. We must shift from code first to data first in building AI agents. So how have we been building this agent so far? So most of us, I believe, uses node graph tools. So you guys might be familiar with these tools. So we have LangFlow, HongFlow, LangChain, and the most famous one, NNN. So the interface looks like this. So why do we use this? Why we love this so much? Because it looks like engineering. It feels very logical. We connect the boxes with wires. It feels good. So we love these tools because they visualize the process. You can see the flow of the application from start to finish. Alright, but then here is the hidden problem. Node graphs like the NAN and LangFlow, they are excellent for designing the logic, the process. They focus on the process, okay, but not on the data. They are terrible for operating the agent. Why? Okay. Think about it, when you run the graph, right, when you run through the graph, data starts flowing from end to end. It starts flowing through the wire like water in a pipe. But once the process finished already, where's the data? What are the intermediate states? It's all gone. You have no clear visibility into the intermediate states. So we call this the black box problem. You have a beautiful map of logic, but the actual data, the most important part is invisible. You cannot see the intermediate states, the reasoning, the retrieval results, the code execution results, or even the tool usage. So you cannot see what happened inside the wire between node A to node B to node C. You cannot see your multi-model inputs or the result produced by the LLM. And because AI is probabilistic, the result is not always guaranteed. I'm not sure if you tried this before. If you use the same prompt and you ask the AI, even though it's the same prompt, sometimes you'll give different results. Sometimes you give correct results, sometimes you give incorrect results. So this is because the nature of LLM models, they are probabilistic. It's not deterministic. The result is not guaranteed. So therefore, visualization becomes incredibly important. You cannot just trust the process anymore. You have to verify the output. So with a graph, it's like the AI agent is driving a car blindfolded. Okay. this brings us to the biggest challenge in the industry right now. We call it the day 2 operations nightmare. So day one is when we build the demo. It works on our laptop, it works on our server, everyone is happy. And day 2 is when we deploy the AI application into production. So real users started using it, and real errors started happening. So when an error happens, the most important question now becomes, okay, what part of the system failed? Which part of it failed? Okay, was it a retrieval? Did we find the wrong document? Did we point to the wrong S3 bucket? Or was it a prompt? Did we give unclear prompt, unclear instruction, unclear system prompt? Or was it a model? Did the AI just hallucinate? Or did I choose a wrong order for the job? Okay. So there's so many uncertainties. So we have to become a detective. We have to investigate the crime scene. Like if you are using a complex node graph, right, the crime scene is empty. The data flow through the wires just disappeared. There's no way for you to actually debug, to investigate. And there's another barrier, the database. So in a traditional node graph workflow, right, where does the data goes? It usually goes to the separate database, be it Postgres, SQLite, MongoDB, or even just a simple log file or a JSON file. So when an error happens, right, you cannot just look at the graph and look at the data. You have to actually leave the graph, you open the database tool, and you have to write your SQL query, or you can just use grep. You have to search by timestamp, you have to pass through JSON objects, you are jumping between your logics and the database. They are disconnected. Okay, now tell me you are debugging it, right? So you are going to the database, retrieve the context. So tell me, who is the AI agent now? You are the AI agent. You are manually searching on database to try to fix the issue. You are doing the retrieval work that the AI should have done. So you are just wasting time, just trying to find a role that matches the error. So in the enterprise world, time is money. We have SLAs, we have service level agreements, then we have to fix the critical bugs quickly. So if you spend 4 hours just trying to find where the data went wrong, in like a spaghetti graph, you will miss your SLA. You are fighting against your clock and your tools are fighting against you. So imagine your manager come to your desk, or even your customer come to your desk. They ask, why did the agent say that? What happened? And because you are using a complex node graph, you are in a trouble because the data is hidden within the logs, and you have to dig through it. So the only answer you can give to your manager or give to your customer right now is, I don't know yet. I need to dig through the logs. I need to trace the JSON file. I need to do SQL query to my DB. So in the enterprise world, I don't know, it's a very dangerous answer. It damages trust. It makes it look like you don't have control. Imagine the deployed AI agent went wrong. Yeah, and the customer asks you, what went wrong? And you say, I don't know. Yeah, then your customer is not going to trust you anymore. Customer will lose confidence in your AI. So what is the solution? So we need to stop hiding the data inside the wires. We need to bring the data to the front end. So this is an upcoming shift, upcoming trend in the industry. Everything that's going to happen with AI agents. So the industry is starting to realize that we need to move away from abstract graph and towards tabular data-centric AI interfaces. So I'm going to give you a bit of examples. We have Hugging Face sheets. So the new approach is like an Excel spreadsheet for AI, where you can clearly see all of the results in each step. So in each column is the model setting, and each row is the entire process. And the data is just presented right in front of you. So this is for V7 Go, and this is on Google AI Studio, so it's all tabular like spreadsheet. And this is Gemini based. So at Embedded LLM, we design our open source platform, Gemini based on this concept. So you can see we have like input and output columns, we have image, and we have all the outputs here. So we call this the glass box architect. So why? Because it's like transparent. You can see everything inside. In the generated table or the spreadsheet, every single row represents one complete interaction with your AI. So it's the entire process in one single row. So everything is stored in one place. So your column A can be like your input, what the user asks, the column B can be retrieval, column C can be reasoning, the column D is your final output. Now, we don't just grab the logs or query the database anymore. We just look at the table, we just read the row and the column settings. And that's how we can debug and verify our output. So here is the magic. The spreadsheet that you see just now, the interface is actually directly showing the database and more. So the generative table you see is not just a table, it's actually the actual data. So this makes the AI agent self-documenting. If there's an error, you don't need to check logs. You just read the row from left to right. So you just follow the flow along. You can see where exactly did the AI make mistakes, and everything is traceable. You don't have to write SQL query to find out what happened. You don't have to search through your JSON logs. The data is right in front of you, organized in row and columns. And there's no context switching. You don't have to switch between your flows, your node graph, and between your database. You just directly fix your data or the model settings in a table. So this will turn like a debugging session from 30 minutes to down to a 30 seconds fix. Yeah. And it's not just about debugging as well, it's about confidence. So because I can see the intermediate states, I can trust the system. And if the retrieval is wrong, I see it immediately. And if the reasoning is weak, I also can see it immediately. The workflow is no longer a mystery. It's not like a pie where you cannot see where the data is flowing through. It is the actual data that can read, audit, and manage. So moving to a data-centric architect gives us maintainability, observability, and traceability to our AI ops. And we can try it out on Java-based. You can scan the QR code, you can go back and sign up. It's free. You also have the open source version on our GitHub repo. You can try it, it's all in the website. So I can now show you exactly how this works with a live demo. Okay. Let me share the screen again. Okay, so this is a very simple AI workflow that I created. So it's an AI agent for hazard reporting. So we can upload an image or any image. We can upload something like this one. Then after I uploaded, so after I uploaded the image, I can click generate. So what powered this application at the backend is actually Gem database. It's connected to the database, and we can call through APIs. So the API to Java is very similar to database. So you have your normal CRUD, you have the update, create, delete. So now it generates the report title, what type of hazard is it? Is it a chemical hazard? And what is the description description of this image, and you tell us what are the safety concerns in these images, and you can tell us what are the proposed solutions to mitigate the hazard. So this is the backend for that application. So this is the Java interface, and we can directly see all the results here. Here are all the intermediate states. So the blue column is the input, and all the oranges columns are the output. So in each column, each of the output column, you can select what kind of model that you want to use. So you can select Qianwen, Cloud, GPT, or even Gemini. And we can do, here's our system, here's our prompt. And then here's our system prompt. And then here are the temperature settings, token settings. And if you want to do RAG, it's just a matter of click. You just click RAG and enable RAG and select the documents that you want to do RAG on. So let me simulate how would the real data come in. What will we look at? So I can add an image. Here I add this image, so I upload it. And you can see it happening in real time. So this is how you can visualize your workflows, and the data is directly there already. You can see it with your own eyes. So if something went wrong, so imagine if this website, something went wrong when your customer is using it, the report title suddenly is giving you Chinese words, or it's giving you wrong words. So you can go back to this table, you can look at the result, and you can start tuning the model right away here. And after you tune it, you just edit your prompt here. Let's say I want to make it not more than 30 words. You just do it here. After the prompt, select back that row and click generate. And all of this can be done through API. So you can integrate to any of your existing software, or you can build a website or front end based on our API as well. Okay, then let me move on to the next example. So this one is a bit more complex. It's for civil engineers. So imagine I have an Excel data and want to turn the experiment data of the Excel into a report the engineer use. I can use AI to do it. So I download the Excel and I click run analysis. So the AI is going to help me fill in all these blanks. And it's going to help me create table as well. And at the end, I can download as a Word document. So let's see at the backend how it looks. So this is the backend. The input data again is the data that we uploaded from the Excel file, and then we can start audit the process. We can see, okay, this column it turns into CSV table data, and this column is extracting all the during depth of the columns. And this column is actually doing calculation for me. It's calculating how many number of boreholes are there. And this column is extracting the names of the boreholes. And what are the during depth is going to convert into JSON for me. I also do some summation, turn into table. And what's the minimum water level, what are the maximum water level. Then finally we can use LLM to help us aggregate all the results. So just like Excel, we can actually reference back all the previous columns. So you can see, I'm referencing the previous column called number of boreholes that we see just now previously, the list of boreholes, the dictionary. So we are using the result of our previous columns to produce new result. So you can imagine this is actually becoming a workflow already. So we have a process, we are linking in multiple times. And then we have the final result, increase the table. And right away we have a report out already, just like that. And today, if your customer find out, okay, there's something wrong with the data, maybe like maybe like a total of 60 meters is actually wrong. The AI is doing wrong calculation. We can go back to this column. Okay, total during that is giving me the summation, right? So I can see what's wrong and I can tune the prompt here. So this is very different from how we work with node graph. So node graph, you have to go to the database, look at the result, and then go back to our graph and then edit the node again. Okay, then I'll move on to another use case. So in Gemini-based, we not only support outputs, we actually also support Python columns as well. So we can actually take any of the column, the content, and use it in a Python script. So we have a small IDE in our column. So this column, what is generating the output is no longer LN, it's actually a Python script that's generating the image. So in this very simple example, I just turn the image into grayscale. And then in Java base, we also support reasoning as well, and we can see and we can look at the reasoning results. So in this case, let me try. So I have this column is trying to describe what are the hazard in the image. So you can see it says thinking, and here are all the reasoning tokens. So you don't lose your intermediate states. Whereas in a node graph, you will usually lose your reasoning tokens as well. You don't know what the thought process of the AI. So you don't know what it is thinking, what he's processing, and why he gives you this result. But in Java base, we can expand it, go back to the thinking, and yeah, we know the thought process of the AI right away. And then here are the answers. Okay, so this is a brief demo for Java base. So you guys can go back and try. And okay, let me summarize the session today. Yeah, so everyone can go back and try Java base. So to summarize, what we are seeing today is that there's a shift in this industry. So for AI agents, we are building applications different from what we are building traditional software on. So we are moving from code first to data first. We are moving from managing logics to managing context, your data, your output results. And we are moving from black box to glass box. We are moving from hidden processes to visible data tables. So this is the formula I want you guys to take away home today, is that visibility equals to maintainability. If you can see it, you can fix it. If you can trace it, you can trust it. So visual nodes builder are great for designing the idea of an agent. But don't get me wrong, I love node graphs as well, because I'm an engineer myself, I love it. But data tables are essential for operating an AI agents in the real world. So for next AI projects, don't just think about how to build it, think about Maker4 as well, think about those operators, think about those maintainers, think about your customers. So think about how you will maintain and choose an architect that will give you visibility. Right? Thank you.
Thank you so much for that question. For now, please come into the middle. Our host has prepared you a Q&A. Thank you so much. So for now, we will have our only 10-minute break for us before the next session. If anyone want to use toilet, again, the toilet is at the exit or the entrance that we've come. And the drink stations and the snacks are all free to pick and drink. Thank you so much.
นด์มากขึ้นต้องมีสแตนด์ได้ประมาณว่าถ้าจะคุยกันก็แค่การลงตัวเองแล้วฝั่งผมก็ยังอยู่หน้าฟองเลยแต่ว่าพอมันที่ถ่ายแล้วใช่ก็เลยแล้วก็เวลาเรียนเราลดลงกันหรอกเพราะว่าเราไปเราต้องหันเวลาเรียนเพราะถ้าเกิดว่าเราเรียนเหมือนเดิมก็ไม่เป็นไร